बेसिक फाउंडेशन त्याचं इलेक्ट्रिक लोकोमोटिव्हमध्येच आहे. इलेक्ट्रिक लोकोमोटिव्हमध्ये आपण 25 kVची कॅटनरी वापरतो. इथं ती कॅटनरी आपण चार्जिंगसाठी वापरतो. मी एक छोटा व्हिडिओ प्ले करतो. मी या पार्टचा प्रोजेक्ट या प्रोजेक्टचा मी काय म्हणतात PI होतो वेन आय वॉज डुईंग दिस प्रोजेक्ट फॉर KPIT. तर this is one of the largest system in Asia as far as charging is concerned. So I am not talking here about 22 kilowatts. I am talking about straight 480 kilowatts into the vehicle. Number one. Number two, it has a pantograph based charging system, down and up. So that is the second thing. And the third thing, when we are talking about batteries, here we are talking about somewhere around close to 200 kilowatt hours. So tonnage by simple by weight, we are at 800 kgs. As far as battery weight is concerned. Then you have thermal system running behind it, you have traction control system running behind it, because at the end of the day, when you want to propel your systems, one is your typical vehicle dynamics, I will not go into it, but at the same time you want to have certain stall torque to maintain, because you have to maintain some gradability out of it. At the same time, when we are maintaining the gradability, you must have enough amperage discharge capacity available from the battery. So there are two things which I am referring to. One, charge acceptance capacity of the battery and discharge capacity of the battery. There are certain chemistries, anyway I will dwell into that as we progress, but at the same time this essentially makes electric vehicle. If you go to your any pass car today, even today, or even let's say Premier Padmini of 1997 or 91, your wiper, headlamp, starter was electrified even then. Only IC engine was the one who was doing the prime mover action. So we call it as a traction systems, right? In electrical we call it as a traction system, there we call it as an IC engine, and then we used to have a gear. Here most of the time we get rid of the gear. The reason is that if you see the motor characteristics, and he will explain you more. So motor characteristics, so when we talk about motor characteristics from 0 RPM to let's say stall torque we call it, to let's say 3000 RPM, where you translate yourself into 120 kmph or 140 kmph speed, then you need a ballpark torque of 700 Newton meters to 1000 Newton meters, depending upon which gradient you are talking, y gradient you are talking, your slip coefficient of adhesion we call it. All this decides the traction controls available on the vehicle. Just go through this video, ask me any question. And this is the largest demonstration project in Asia. There are 25 buses running on the road. If you by chance visit Malaysia, go and see that this is the fastest charging system available in Asia, and perhaps 4th largest in the world. So to give you
NANO has been conducting a demonstration project in an urban transportation system using large-sized electric buses. This demonstration is being conducted in Malaysian city of Putrajaya. Putrajaya is approximately 25 kilometers south of the capital of Malaysia, Kuala Lumpur. There are many government agencies concentrated in Putrajaya, and the city is promoting development of EV-related industries as part of its urban planning in pursuit of the establishment of a green city. This is one of the reasons why NANO has chosen this location as a site for the demonstration project. Operating large electric buses on major routes. Those buses are 12 meters in length and equipped with long-life, super-quick charging storage batteries.
So again, you know your vehicles, right, on the road, your Tata vehicles, right, or Ashok Leyland. So you have 7 meter, 12 meter, all that segments are there. And accordingly, if you go to UNEC norms, like if you go to UNEC website and how they classify the vehicles. So you have L, M, N classes, and this vehicle falls into M3 class. So go ahead, read it, because these are various classes that define. That again goes back. This is, I will say, the master directory of the vehicles, meaning how you define the vehicle, what are the implications of definition, what are the architectural rules we have to follow, because finally all these vehicles need to comply certain safety norms. And you must have heard ASIL C, ASIL D, all that, ISO 26262. I will not dwell into it, but I will just, so all these vehicles have to have major 4 systems or 5 systems, and they all work in union to give you a seamless user experience. The first system, as I mentioned, battery. Second system is traction. third system is charge control, fourth system is aux control, aux power control, and fifth, which is nothing but body and chassis system. Because these vehicles, right now our buses are, I will say, plain chassis, meaning they don't tilt or anything, but these vehicles have all necessary aerodynamic as well as the necessary center of gravity control mechanisms in place. So this vehicle practically tilt, and when I say tilt, we tilt this vehicle till 25 degrees. So you can practically imagine, like you are like on the slanted slope, you are standing like this. So direction of movement is this, and vehicle is practically on other side. So that all dynamics need to be considered, and while doing that, there are a lot of tests. If you want to go to FMVSS, that is a statutory body who describes the various vehicle dynamic tests. So go to that, and these vehicles, as I said to you, they are they are essentially equipped with the batteries which are super quick charge, capable of accepting charge very quickly. So 10 minutes, 200 kilowatt hour done, and you can go for another 150 kilometers. So right now, if you see, only 4 countries have that kind of super highways available. One is Germany, second one is Malaysia, third one is in Switzerland. If you go to ABB's website, then 500 kilowatt systems are there. And fourth one, hopefully we are talking about that Rajasthan Jaipur highway. Most probably we will have that kind of system. So these vehicles are equipped with that. It has a thermal cooling system to make sure that your traction cooling, your DC-DC cooling, and your charging systems, or I will say battery cooling systems, are managed so that your temperature never goes beyond 35 degrees C. Because note, when we are talking about battery cooling system, the essential parameter of the battery cooling system is all about how you maintain your temperature of the battery. Number one. Number two, how you really manage your charge discharge rates. So if you try to, if you have any time done a battery characterization, which is a key of battery systems, then you will realize that the charge acceptance capability of the battery and chemistry of the battery has a strong correlation. For example, LTO chemistry can go up to 4C, C being your AH capacity of the battery. NMC goes 0.575C, which is C is your again installed capacity of the battery. And again, with respect to voltage, you play the gimmicks. So this is 400 volts DC system. Double deckers, what we have also deployed here, are having at 600 volts DC. And all our traction systems that you see right now is 25 kV single. So single wire earth return system we call it. He will explain you more. He has developed 2 megawatt converters.
ネドは環境に優しい都市交通システムの実現を目指して2015年7月にEVバスシステムの実証実態大量の EV バス導入が期待され
So this is a pantograph based charging system, and when I say pantograph based charging, it is fully automated system. It is not your like normal vehicles, right? You go and plug the system and then vehicle detects it and then you start it and all that. No, driver sits inside the cabin, goes below the pantograph, aligns the vehicle, alignment tags are there in the system. We give online instructions, so to the vehicle to move vehicle backward, forward, left, right, whatever. So center alignment is done, then all you see the LEDs are there, blue, red, and you will see in that video. So these LEDs essentially are reflected inside the cabin at driver dashboard, so that driver knows exactly where the vehicle is from the point of I will say charge gun. And this is pantograph up system, meaning from vehicle system will go up. There is charge camera there, so that any flashovers or anything that even by accident happens, driver knows that there might be a possibility of fire hazard and he can disconnect the vehicle in case of emergency. Otherwise, the vehicle itself has all emergency evacuation procedures allotted to it. So in case of flashover, temperature rise, your current imbalances, voltage you name it, all are incorporated in this vehicle. So even a smallest, and to give you an example, this is 800 amps charging system to be precise. So in 800 amps, we are measuring the current up to 1 ampere. That is the finest resolution we are getting. And why we do so? Because there are 8 battery branches which are connected in parallel to deliver that 200 kilowatt hour. So to make sure that kilowatts are maintained, number of kilowatt hours are maintained, between the battery branches SOCs are maintained, between the battery branches SOH is maintained and temperature is maintained. A lot of safety checks and algorithms are going in. So hence I was saying that electric vehicle is not just per se it is running the motor, it is amalgamation of all these technologies controlled by vehicle control unit, which is sitting just below this deck, upper deck, and you can practically see it if any electric vehicle is here on.
弊社によって高品質で超寿命超急速充電が可能な電池を搭載し
So, see here, I will show you here. This is your typical charge gun point, because this kind of vehicles might need an auxiliary power when it gets halted or it gets main charger get deprived out of power. Because to give you an example, when I was doing this exercise, amount of load we were putting on the grid at any point was 2 megawatt. At any point, because we are having 5 to 6 buses simultaneously charging at a point. So 800 amps, you multiply the numbers, you will see that you are around 2 megawatt in total. So reflected power at a grid was 2.2 megawatt, and we literally we had a separate feeder, or we have a separate feeder to tackle this kind of load. So hence I am saying electrical vehicles, and if I compare the electric traction, that is our locomotives, I will say they are ballpark very close when it comes to the charging requirement, when it comes to the current delivered by the motors or current absorbed by the battery packs. And they are employed with the yeah.
10分間超急速充電方式による大型 EV バスシステムの実証を行い、その普及を目指すものです。また、現地企業と連携しながらこの実証を進めることで、マレーシアの環境産業政策への貢献も目指します。
Kupichan and the two routes for electric buses are circulating station, the bus terminal.
So, here is one display. I have a pointer here. Okay, here. So, to the white, I will say canopy दिसती है ना, that is your typical charging infrastructure. Because when we are talking about, मैं आप फोटो तक आएगा. ये white canopy again. This is, we have underground 11 kV system coming there. We have step down transformer 690 volts, and we essentially manage the buck boost required for, and it is fully isolated. So only HV plus and HV minus. There is no ground here. It is all completely floating system. In railways, you are using your tracks as a grounding mechanism. Means like single wire earth return system we call it. Here there is no ground. So HV is completely floating. HV plus and H. So we have impedance monitoring here, which is very crucial, because we all know it is first it is DC. Second, we are handling high voltage. No, it is like 600 plus minus range. So right now, if you see on the LinkedIn and all that, people are talking about 800 volt architecture, 600 volts architectures, and incidentally, almost now, today is 24 now, minus 4 years. So in 19 we commercialized these vehicles, and as I said to you, when you go to Kuala Lumpur, Putrajaya for your sightseeing or anything, check the kind of ride comfort, kind of regeneration we are talking. And when we are talking of regeneration here, single wire earth return system of electrical traction system, it is not that high. But here we are talking about regeneration of 100 kilowatt, meaning at 600 volts, we are pushing back close to 400 amps back to the battery. Okay, so we call it as a regenerative braking. You must have heard it, and we deploy it here. So when you are sitting inside the vehicle, the dashboards are arranged in such a way to give that flavor. Like what is the braking? When you press a brake pedal, what is the percentage of regeneration energy we are capturing back to the battery, right? And that's how that 4C, 5C charge discharge. Not able to hear? Okay. That's how that charge discharge battery packs are getting controlled. So it is really most, I will say, most advanced system as of now, and technically extremely challenging, because these are all pantograph based system. This is not your normal conductive coupler charging system, fully automated, that we are talking about.
New service routes for electric buses are circulating within Putrajaya and connecting the city with nearby Cyberjaya.
Completely telematic systems installed on these buses, meaning you can practically locate the bus, where it is standing, why it is standing, any faults, any diagnostic one need. use. So we are using, if you have gone through ISO norms, so there are prognostic protocols, diagnostic protocols. All these protocols are implemented, and you must have heard CHAdeMO, CCS, all these standards. Now in North American standards are also implemented in Tesla's cars and now Cybertruck. So all these protocols are implemented on this vehicle. So it is CCS compatible, CHAdeMO compatible, and on top of it, this vehicle are first of its kind who do V2G. We are still hearing that V2G word, right? So V2H, V2G, V2L, all that stuff. So this vehicle can do vehicle to vehicle charging. So let's say this bus goes off because of whatever reason. Let's say SOC goes down. Then the second bus, which is on the road, can practically connect to this bus and do the charge top-ups. And both bus can go for, let's say, another 50 kilometers, 60 kilometers, whatever that mileage desired. So online, I will say on-road charge balancing, quote unquote, is possible in these vehicles. It is demonstrated, and in fact, if you go to NEDO's website, there is plethora of literature available for this, starting from architecture, your charging protocols, and so on and so forth. Yeah.
We are boarding the electric bus on a route looping through the city. It starts off a little jerky and accelerates smoothly, and a quiet interior, a major benefit of electric buses.
By chance, any guess what is your acceleration here? Because we are talking about like 100 kmph in 8 seconds, 9 seconds, 10 seconds. What should be the acceleration numbers here? But without feeling any jerk, passenger should not move backward. That is the condition. And same thing, when you are braking, he should not move forward. Any chance? Any wild guess? Okay, what is the rise rate of torque here? Any guess? At what rate, at what slew rate I am rising, making the torque from 0 to 100? Let's say 100 is your peak torque.